My name is Marko Lehtimäki. I'm the CEO of Donut Lab. The industry we're in is the global electric mobility market that is projected to grow from $500 billion to over $4 trillion over the next 8 years. And this includes, in addition to automotive, also drones and all other types of vehicles, okay? But any transformation of an industry doesn't happen just by the incumbents. A lot of the change will be driven by the challengers, young companies that are scaling, that are building new ideas, that are challenging the status quo and doing things in a way that nobody's ever done before. And we have some of those amazing companies here today. But there's a couple of problems in the automotive and EV industry that hinder the innovation, the speed, the ability to move fast and make great things. One of them is that it's really, really hard to build EVs. Really hard. Ask German automotive companies, or ask anyone trying to build great EVs that beat the ones that I'm not going to name here. It's really, really hard. And it's especially hard for startups. Imagine being a young company trying to figure out how to build an entire vehicle. Been there, done that. It's not easy. But it also takes a lot of money and time. Vehicle programs will cost from hundreds of millions to billions. That's not a great kind of environment for startups to thrive if you're going to spend hundreds of millions to build something amazing. Who's going to believe you? Who's going to give you the money, the seed money of 100 million to build something exciting? But it's also the same for the large automotive. These programs are very expensive, but not only that, but it takes too long to build vehicles. And we're here to fix these things. The reason why it takes so much money and time to build great EVs is that we're doing it wrong. We're building vehicles out of components that have not been designed to work together. It's like trying to build a house out of Lego blocks that don't fit. That's not a very good way to build it. You buy motor from this guy, motor management from that guy, battery module from here, vehicle control unit from there, and then you integrate and spend 80% of your time integrating things that were never designed to work together. It used to be the norm that you would use a spacecraft once, right? And then somebody challenged that thought. All of a sudden it's 10 times, 20 times, 30 times, 50 times cheaper to go to space. We're doing something similar here. And what we're doing, what we're building, is the world's first electric mobility platform with a modular architecture that allows you to build vehicles of all categories without all this pain. What it consists of is the essential components, the motor, the battery, all the electrical systems, the brain, which is the main compute unit, and then unified software architecture and layer that makes it all work together perfectly. And all of these are a suite of best-in-class components designed and built by the Donut Lab over the many years with a unified software layer that just changes the way how we build things. One of the benefits is unbelievable performance. You will hear about that today in factual, real numbers. It is more performance, more torque than what you've ever seen before. Another one is incredibly fast development. When you can cut all of that integration work out, you can build really fast and really awesome things. And with that comes the development cost, which will be a fraction of what it used to be. And the final benefit, lowest possible cost for the bill of materials. I'll get into this later in the presentation, but it's really true that you can get all these things and the best performance while lowering the bill of materials. We call it the donut platform, named after the donut motor that is in the center of it all, and I'll share more about the donut motor later. And we are launching it all today here with our incredible partners that will come on stage later. But first, I want us to watch together an epic film that we put together that displays some of the vehicles that are launching here today that are building on top of donut platform. Let's watch it together.
Have we forgotten that change doesn't just happen? It's built by those who dare to dream it. Paths are only carved by pioneers. Why should we stop where the road ends? When did dreams become small? Who decided skies were the limit? One heartbeat, one pulse, one shared foundation, a new era of motion. An electric platform that adapts, scales, evolves. Simple, agile, limitless. Across skies, roads, and every frontier, we're not just imagining the future, we're building it. The donut platform is where we start and where we transform.
Alrighty, are you ready for what's coming? I'll share a few words about the components that make all of this possible. And we'll start with the most important one. Motor is really the heart of any EV. It's in the core. But when you get to design an EV architecture, a universal one, from scratch, you better make sure that you do it right. And we spent a lot of time thinking how to build these components so that they will serve the market in a way that nothing has been able to do before. And so we had to start from the first principles, kind of thinking of what does it really mean and why would we do it this way? And motor was one of those components that took a lot of time. And the fact is that everybody in the industry hates the power transmission. And the reason is that it adds a lot of weight to the vehicle. If you could put the motor in the wheel instead, you'd be so much better off. The power transmission increases the cost, consumes a lot of space, adds complexity. All the moving parts are from power transmission. And those moving parts require maintenance. But power transmission also reduces efficiency by a lot. And that energy that doesn't get delivered to the wheel turns into heat. So you need more cooling. But it's not only these things, there's so many more. For example, you could theoretically control electric motor 1,000 times a second. But once you add the power transmission, you lose that. You're able to adapt and control maybe 1/50th of the accuracy or 1/100th of the accuracy that you otherwise could. So we decided that donut platform will not have power transmission, and none of the vehicles that built on top of what we have will. That's why we built the donut, which is the world's best motor by any parameter, and it's right in the wheel. It is a motor family that we patented, and it is the world's first rim motor. And it really does change everything. Once we get to the numbers, you start to realize that somebody should have thought about this 50 years ago, but they didn't. As a matter of fact, one German engineer told me early on, this will never work. I asked why. He said that because a German motor and so forth manufacturer would have invented it 50 years ago and patented it. And we would use nothing like this, nothing except for this. And so, but the status quo is sometimes so strong that it's hard to change things. That's why you need people who think outside the box. This motor molds to your needs. You can use it in any application, in any shape and form. When you make it wider, you increase power and torque. When you increase the radius, you increase power and torque. So it's really almost like clay in your hands. Whatever type of vehicle you want to think of, how much torque and power ever you need, donut motor can deliver that. The other one is what we call the pack, and that is the battery, the modular system that we created that provides high performance, really, really fast charge times, and incredible efficiency. The pack is also in the core of the donut platform. On top of that, we have what we call the brain, which is our high-performance compute unit for sensors, for local machine learning models, for decision-making in EVs, and it's built for the future. It comes with built-in GPS and IMUs and all the things that you would want to have in your vehicle. It supports large amount of cameras and radars and all the things that the future needs. And it easily integrates with all the control units of the vehicle. And on top of all of this is the software that we've designed to take the best out of these components, and it works seamlessly together with the hardware. Now you may ask, what does this all mean in practice? And I'll invite my dear friend on stage to share more, Lauri Laukkanen, the Chief Marketing Officer of Verge Motorcycles. Come on.
Hi guys, I'm Lauri. I'm the Chief Marketing Officer of Verge Motorcycles, and I'm pretty excited about today. I, of course, have very much an insider's view into what Donut Platform can do for a product, and I'm going to talk about that a little bit today. Like Marco said, we've done the practically impossible. We've already created and built and are manufacturing an EV. And it's not just some sort of an EV, it's actually the most advanced motorcycle out there. And it's the first product out there that is utilizing all of the components that you'll find in the Donut platform. So it's the perfect showcase showing what the potential of this platform is in a vehicle. What you see here is our crazy beast, the TS Ultra. It has torque of 1,200 Newton meters, a range up to 375 kilometers in one charge, and that charge, 25 minutes fast charge. You'll be speeding down the highway 0 to 100 kilometers per hour in just 2.5 seconds, so make sure you're holding on tight. But what truly makes our motorcycle special is its unique architecture. And how we've gotten there is all because of the components in the Donut platform. A motorcycle is a really tough form factor. You're putting a lot of components in a very small space. You have the battery, you have the motor, you have the control units, the electrics. Everything goes into such a small thing that fits between your legs. But what we've done and what the Donut platform has allowed us to do is we've been able to move one of the biggest components, the motor, away from the body. And this has unlocked a totally new way of creating and building motorcycles. So what we've done is we have the Donut motor in the rear wheel. So it's integrated straight into the rim. What this brings to us is that we've now freed up the whole body for the battery pack. We have a bigger battery pack, we have more range. We can lower the battery pack down, and we have low center of gravity. Now we have better handling, it's nimbler, it feels lighter, it's just overall better. Having the rear rim motor in the back wheel transfers all of that raw power and torque straight into the road. There's no power transmission, like Marco said, at least we, and pretty much the whole industry, hates power transmission. And getting rid of that power transmission means there's no moving parts other than the two wheels. Again, we're reducing weight, getting rid of all of the unnecessary complexity, and at the same time, also minimizing the maintenance. There's no moving parts, no oiling, no gears, no chains to look after. It's just easy, it works. Improved safety and reduction of noise, things that come from getting rid of all of the unnecessary things that you don't need in a motorcycle, but just have been there because, again, no one's been, I don't know, crazy enough to innovate and think of it in a new way. So, of course, we think that we have a crazy product in our hands and it's advanced and super amazing. But it's not just us, it's the media as well. Looking at what we've done in the past 2 years, well, 6 years from the beginning and now 2 years manufacturing the bike, the media has gone crazy about what we've done. And it's understandable. It's something totally new and just so much better than anything out there. But of course, in the end, what matters the most is what our customers and consumers out there think. And we've entered a very interesting time in the past year. We've opened up showrooms in Los Angeles, in Santa Clara, London, Germany. And now every single day, thousands of people are getting introduced to our brand, to our bike. We're doing test rides every single day. We're attending events, showing how great the bike is, and the response is amazing. And that, of course, excites me as a marketing person, because in the end, it's all about that final piece in the puzzle. If we think it's nice and no one else cares, who cares? But everything that you see here is just the beginning. Verge TS is from where we started, and I'm happy to announce that next year, you'll be hearing quite a lot of exciting stuff from us, and I can tell you it's somehow related to what Donut Platform is doing. Thank you.
Thank you, Lauri. All right, so you heard about the motorcycles. As said, Verge TS is the first consumer production vehicle shipping every week that uses Donut Platform. But today, we are going beyond motorcycles. We are bringing Donut Platform today to four-wheelers and beyond. And all the benefits that you can get with it, such as the torque density and the power density that is able to provide the kinds of numbers that Lauri shared, are now being brought to every EV. Torque density means how much torque per kilogram can you have in the motor, or how much power can you generate from the motor per kilogram. And the higher the number is, the better the vehicle will be. It basically means greater performance while reducing the weight, which is something that automotive industry is super excited about, while decreasing the cost, even more excited. And we are finally removing the entire power wheel transmission from every EV category. It's really, really exciting because we will see the kind of vehicles that have not been possible to be built before. And all these benefits that Lauri mentioned of the Verge TS and TS Pro and TS Ultra, all of those translate 100% to the automotive application. Some even more relevantly than in a motorcycle, because you have multiple motors. And next up, I'll invite another dear friend to go deeper into the in-wheel motor and its specific benefits to the automotive industry. I'm excited to invite on stage Hayden Baker, co-founder and COO of Donut Lab. Come on.
Good afternoon, everybody. So my name is Hayden Baker. I'm the co-founder and COO of Donut Lab. I've been in the automotive industry for 37 years. And the first 20 years of that, I was a studio engineer, concept engineer, product engineer, launch engineer. And over the last 17 years, I've been involved in program management. Over a decade at McLaren, and 3 years at Rivian, and then the last 4 years solely in the EV startup space. During that time, I've worked with many fantastic engineers and working on groundbreaking technology. Just 15 months ago, I was introduced to Verge motorcycles, and that's where I met the genius behind Donut Lab. And I have to say, I'm working again with equally skilled engineers, but in my opinion, even better technology. I have no doubt that the automotive industry is ready for Donut Lab. I will talk today about the Donut platform, as Marco's alluded, but it does start with the in-wheel motor benefits. And here are some of the highlights in terms of packaging, low part count, control and digitalization, safety and dynamics. I'll highlight some of these on the following slides. I was a concept and a packaging engineer many years ago, and to have this solution would have solved so many of the packaging problems that I have seen in the past. The holy grail of the flat floor design becomes almost standard with the Donut Lab platform, which gives the flexibility for luggage placement and, of course, increased cargo capacity. We recently finished a study on an SUV where we're looking at the part count, amongst other things, and 118 parts were deleted from that potential program. And some of the highlights being the drive shafts, differentials, handbrake, wheel speed sensors, gearbox, and wheel bearings. The Donut Lab platform, the thing it gives you, whether you're in the early R&D phase through concept or all the way through production, is ultimate control. So the vehicle will be up and running, doesn't matter whether it's a mule that we're starting with or towards the end of production. Some of the highlights are the high bandwidth control at 10 millisecond intervals, independent braking hundreds of times a second, precision torque control on each individual wheel, and acceleration control faster than traditional ABS systems. This leads into the digitalization with digital control of vehicle handling, enhanced stability through active suspension, precision steering, and independent wheel control for optimal traction. Can't have a conversation without talking about safety, and everything that we have in the Donut Lab platform meets all the automotive safety protocols. And in certain instances, we feel will enhance in terms of emergency redundancy for braking, shorter stopping distances for quick response, enhanced stability in emergency maneuvers, and improved control on low mu surfaces. This continues through to dynamics. So with the software controls, driving dynamics, enhanced steering feel and responsiveness, improved drivability, and it enables over-the-air performance updates, which is what we currently have on the motorcycles. At heart, I'm a pretty simple program manager. And when I think of all the programs that I have done, where I've written specifications, I've done timing plans, I've done validation plans, I've done bills of materials, I've done costing, business cases. Every one of those programs, if the Donut Lab platform was available to me at the time, I'm pretty sure I would have adopted them, because every business case would have been better. We'd have had less parts, less risk, more performance, less warranty, less hours to manufacture. In my opinion, the automotive industry is ready for Donut Lab platform. Thank you.
Thank you, Hayden. Really, really exciting. And by the way, all these benefits that Hayden shared are unique to our platform. So there's so much to share about that it's crazy. But these are also the things, as we've been discussing with major OEMs in the auto industry, these are the exact things that gets everybody excited. In addition to what Hayden said, we've been actually doing feasibility studies. We've been working on different types of concepts, and this is one of the programs, virtual programs that we've been designing. And here's the anticipated performance metrics of a single solution that we designed. Of course, you could do something even crazier, but this is one of the SUV examples that we've been working on, which would beat pretty much everything else in the market in the important numbers. But here's some more information on the study that we did with compact SUV. Bill of materials savings, almost 2,000 euro per vehicle. That is absolutely crazy in the auto industry. To be able to get that much bill of materials savings is beyond imagination for many. Getting additional cargo space, like Hayden discussed earlier, and a lot less parts, almost 75% of the parts. And that means that your manufacturing is also more streamlined. But the shorter R&D time is one of those things that every advanced engineering group would be very excited about, because that's where the innovation comes from. A lot of people would be ready to pay a lot of money to get 1 kilo of the vehicle. But with this compact SUV feasibility study we did, we're able to eliminate 85 kilos of the vehicle. Those of you not from the industry may not know how big or small that number is, but that is a really big number. But we didn't just study SUVs, we also looked into hypercars and supercars. And here's hyper GT car concept that we worked on. And we were able to reduce almost 10%, 108 kilos from 1,400 kilo vehicle, which is ludicrous. With the power to accelerate from 0 to 100 with less than 2 seconds. Crazy beast, while being able to reduce the drivetrain bill of materials by 55%. And freeing up 200 liters of packaging space in a hypercar is no joke. We've been also looking very closely into semi-trucks and the heavy transport industry. The bigger you go, the bigger the savings. We're able to deliver incredible 18,000 Newton meters of torque while reducing over 1,000 kilos from a single vehicle. And when you reduce the bill of materials almost by 15,000 euro per single vehicle just by adopting the platform, you get every executive's ears listening to what else can you provide. Imagine being able to increase a cargo capacity by over 1,000 kilos just by adopting the donut platform. But how about other type of commercial vehicles? How about electric buses? Well, I'm excited to invite on stage a person who knows more about these than many people in the world, Juha Christensen, the founder and CEO of Nexus e-bus.
I arrived 3 days ago from my Singapore office to Finland, and I have to say I love yesterday and today, the weather. And I will come in a minute why. When we look to electric buses, it's different from motorcycles or cars. Motorcycles and cars, you have customer who likes the fit or likes the driving. But when we talk about electric buses, what is really key is the operator's perspective. and how to do profitable operations. Number one, reliability. Number two, energy efficiency. Number three, durability. Electric buses in city drive 75 to 100,000 kilometers per year. Lifespan is 15 to 20 years, so you drive 1.5 million to 2 million kilometers. And number four, well-trained and motivated bus drivers. These all bring operational advantage for the operator. Now, Nexus will be bringing next generation 5.0 electric bus to the market. It's of course based on donut labs in wheel motors, but actually the whole platform that you have already been introduced and heard. It is a full aluminum chassis and full aluminum body, of course reducing the weight and giving some other benefits. And it will be the first real four-wheel drive electric city bus in the world. And for a reason. The reason, number one, is of course that we can enhance the recovery of the braking energy. But number two, now I come back to the reason I said I liked yesterday and today. In the Nordics, we have more than 70 days, slippery days. Maybe not in the Denmark, but definitely in Norway, Sweden, and Finland. And this will, of course, be bringing remarkable driving improvement in slippery roads. And not a small thing, there is a huge stress on the bus drivers to be on schedule. And of course, four-wheel drive is going to bring an additional advantage and safety for them to be on time in operations. Now, I don't need to go through all the previously mentioned remarkable advantages. Those all that were mentioned translate 100% to an electric bus. But the most important thing is, that was mentioned already by Marko, is one system integrator. We get the powertrain, we get the in-wheel motors, and we get the software from the same provider. And this is one of the key things that we immediately decided to go forward together with the Donut Lab configuration. And of course, like already mentioned, reducing the overall manufacturing costs. We will be meeting minimum 5 to 7% energy consumption efficiency. And just a sample, Nexus e-bus, 12-meter solo bus, just technical details, between 375 to 450 kilowatts, and operational city range will be between 325 to 400 kilometers. And last but not least, the first bus will be rolled out Q2 2026. Thanks a lot.
Thank you, Juha. Alrighty, so we've now heard what the Donut platform can bring to the motorcycles, the SUVs, hypercars, trucks, and even buses. But we haven't heard anything about off-road. And to tell you something more about off-road use, I'm delighted to invite Eric Pastor, co-founder and CEO of Aruga. Welcome.
Hello, hello. Hello, everyone. I'm very excited to be here, and someone to block my line of the snow and these days. I was gonna use it. I would like to warm up all of you guys. How many of you like outdoors? Like Finnish people, like 99%. I'm from South America, and like winter is something that you think twice, but over time you start loving it. And that's when we get about outdoors. This is the Oruga Unitrack. It's the world's first single track off-roader. Imagine that a tank was dating a motorcycle. And actually it took us 9 months to build this vehicle. So it's kind of matching right now. And this is what we have. The power of the track with the maneuverability of a motorcycle. That's a lot of power between your legs. And powered by Donut Lab. We are addressing several key challenges in outdoor for traditional vehicles. You have small contact area and a clearance from those who have driven. Some of you have driven snowmobiles, yeah, okay. Quad bikes, yeah, bicycles. All right, that's okay. If you know how to drive a bicycle, this will be easier for you. Insufficient clearance is a problem on that, and small contact area too. Then we have the other part is the vehicles right now in outdoor, they are very good in a specific domain. And then when you want to have better performance, you need to switch to other vehicles. And of course, in the last 50 years until now with Donut Lab, there has been only incremental innovation. There has not been radical innovation. There have not breakthroughs in technology. Everything has been just stop and incremental innovation. Now, just imagine you are in Tartu, or you are in Riga, or you are in Stockholm. Sunny day in summer, flowers are glowing, you are happy there. Suddenly winter comes. You choose your own vehicle, you are stuck there in the middle. And then, okay, winter, okay, I switch to my snowmobile. Winter is gone, you are stuck in the mud. And then there is too much snow, there is too much mud, there is too much sand, and there is too much rocks. What are you doing? Is it an adventure or is it a disaster? That we don't know. So we're coming into that. So contact area and clears are important. Quad bikes has around 900 square centimeters. Adventure bikes have around 300 square centimeters, and they have a long area for those who do this. Depending on the vehicle, you know how to move, what to avoid, when not to get, what to do. But with the Oruga Unitrack, we have 13 times more contact area than a motorcycle, and 4 times more than a quad bike. And why is this important? Also, we have zero clearance. It's because it gives you superior stability, you have lower ground pressure, and maximum traction. The maximum traction you can get, and now with Donut Lab, we will have even more. Okay, there are other factors for traction, weight, the type of terrain, and so on. So if you have a vehicle, your belly is a problem, not my belly, the belly of the vehicle. That is a problem. Going to the limit cross-terrain platform, they are, as I say, snowmobiles are great. The Oruga doesn't want to replace those vehicles. If you are limiting a one terrain, keep your snowmobile, but when you want to move around it, quad bikes, sand dunes, and dune buggies in sand dunes, or if you have a bigger vehicle in rocks, you would choose that. The interesting thing is we found an opportunity for a business. Us as a startup, we see that we can build a vehicle that can move efficiently, versatile, can give you fun, and is a convenience for business through different terrains, avoiding 2 critical things. You don't need to modify your vehicle when the season changes, and you need to have another vehicle for that. In the last 15 years, the last point of innovation, we have 3 streamlines of technology. All the vehicle manufacturers went to exploration, definition of the product, and then enhancement. And now with Donut Lab and Oruga, we are breaking this tendency of having just incremental innovation. The Oruga Unitrack provides you the maximum traction across terrains in any season. And we just managed to do this before the presentation, knowing that winter and snow was here with us. Okay, so we have a proprietary track system, 3 patents already filed. We have the world's first steering and tilting capability. It's not easy to try to steer a track when it wants to go just forward. That is one of our key advantages. And also is a known capability. This means that if you know how to ride a bicycle or ride a motorcycle, this will be easy for you to adapt. And because we are using Donut Lab, we will become fully electric. And probably in the future, we are thinking on a hybrid version to have even longer range. Our initial specs are around 200 kilometers range with the generation 1. Why not more? Because we still need to test How will the performance went when you are accelerating too much in mud and then you need to accelerate in snow? So your performance can vary. Speed, we can go higher than that, but I'm not sure you want to be in the rocks at 120. It's like, you will think it twice or you just raise your life insurance. Then charging around 1 hour and the torque more than 1,200 Newton meters. That's fantastic for us. We need a lot of torque to move that beast over there. So far, with this, we're getting to the end. We're targeting North America and Europe for business. If you have a business that operates outdoor, like mining, land management, oil, or you have trail operations, adventure, this is the one for you. If you are an outdoor enthusiast, you are a hunter, you will avoid heat signature, smells, and other things. If you like to do trail adventure, this is the next generation of vehicle for you. And our status, you can see the real prototype downstairs is the first one working. We finished last week. We incorporated now 2 advisors that will helping us with the development of the product. And we are very happy to that. My team is here, and thank you for the hard work, guys. That was awesome. Yeah, why not? The gap in the market is, there is a cross-terrain gap in the market. Like, everyone is focusing on city, and after COVID is, hey, let's go to the mountains, let's go do it slow, but hey, we don't have the right vehicle for that. There is a market gap that we are going to fill. The electric growth in outdoors mobility is growing, and people are looking options that are not gas combustion engine driven. So then with Donut Lab, we have the perfect match. This is a vehicle for ending. Why are we choosing Donut Lab? First, because this is an integrated system. It helps us reduce cost, time to market, deal it with other kind of different suppliers. That's a nightmare. We already tried it. We also has the highest torque density. And something that is important for me as a co-founder is that we share the same vision that Donut Lab has. It's like changing and transforming the automotive industry in our particular niche. It's what we want to achieve. But with Donut Lab, it's not only one niche. You saw that you can have a full platform. If you are an entrepreneur or you have an idea on a project, Donut Lab can help you with that. And as a startup, we are around 1 year old, a little bit more, and we have our first prototype. That's crazy. So many, 3,000 hours to achieve that first prototype. If you're a startup, I'm representing them, having a European supplier is very important. We have tried to get Chinese, Taiwan, India. If you want to deal with too many suppliers outdoors, you will have complications. So it's better if you have one supplier near to you. And the last part is collaborative R&D. You're going to build your product. You need to have clear contact with your R&D team and the Donut Lab team, or a supplier team. So you will have challenges in understanding some things. If you do modifications, you want to do it fast, you need to have accessibility to R&D team of your supplier. And Donut Labs will provide you this. If you see the image, in our case, we are using 2 donut motors because we need to balance the weight. And we have a front part that is a bit heavy, but we are modifying that with the battery pack and with the weight of the driver. And yeah, that's it. So I'm eager. If you have any question after this, we will love to talk about it. Thank you very much, guys.
Thank you, Eric. Super exciting. So now we've heard it all, right? We've talked about on-road, off-road. But what about the sky? Is sky the limit? I'm excited to invite on stage an Australian Air Force fighter pilot who's going to talk about the need for speed. Welcome on stage, Peter Baden, founder and director of Hyperq Aerospace.
Thank you, Marco. My background started in the RAAF. I spent 14 years training to become a fighter pilot. From there, I went on to fly commercially. I've flown domestic and international aircraft all over the world. and for the last 13 years I've been involved in the unmanned community. I was fortunate enough to check out on the Mirage 3 fighter aircraft. That aircraft has unbelievable performance, 750 nautical miles an hour, around 1,500 kilometres an hour at low altitude. At high altitude, twice the speed of sound, Mach 2. And we can climb that aircraft at 75,000 feet as a service ceiling. It was a remarkable aircraft to fly, and I had a whole bunch of fun firing missiles, in being involved in international exercises, flying an aircraft that is unprecedented in its performance for its design time. But one particular day, I was out flying on an air defence exercise. Been 3 days with nothing to do but sit on the end of the runway doing a standby for an alert scramble. And I got that scramble. Headed out under the control of the GCI, the ground control intercept controllers, to go to chase F-111 aircraft, our nominal target on that particular day. So myself and my wingman got airborne and we flew out to about 30,000 feet altitude, doing around 450, 500 nautical miles an hour, and were vectored onto the F-111s. We shot both of those aircraft with our nominal Matra 550 heat-seeking missiles. Those aircraft kill removed, and we were then stationed back on combat air patrol. We maintained that position for around about 15 minutes, and then I got a vector from the Navy control ship that took over the control of this operation to vector me at low altitude to chase another incoming bogey. That bogey happened to be one of the previously kill-removed F-111s. Needless to say, it was now making another ingress to attack Williamtown, our fighter base in New South Wales. I was vectored toward that aircraft and gained visual on that bogey around about 1.5 miles away from where I was. And I closed, but the problem that I now had was I have no missiles remaining. Without missiles, I've only got guns. So I needed to close to very close range on that aircraft. And in Mirage parlance, that had to be inside 600 hectometres, 600 metres. So I closed, got within about 1,000 metres, closed again, 800, 700, and believe it or not, I got an afterburner firelight. Bugger. Am I going to continue with the attack and take that gunshot, which we've been missing for the last 3 days, or am I going to do the right thing and just peel off and climb to altitude? Which I did. After I levelled off and completed the emergency checks, the engine failed completely. I had to eject. I had no choice to stay in the aircraft. And this is where I ended up, in the water, now trying to survive, get myself under control, climb into the life raft that I was provided with as part of my ejection seat, and then ensure that I still have an opportunity to be rescued. My fighter pilot wingman made contact with me with a portable radio that we had to say, helicopter's on the way. So here I am now, keeping my fingers crossed that there's no great big snapping white sharks out in the ocean. Always a problem. Subtly, I'm also concerned about the fact that with overwater ejections, there's only a 20% survival rate. I didn't need to be there for very long at all. But it was nearly 20 minutes before the helicopter turned up to rescue me. So I'm sitting there, a little concerned about getting back home tonight. Needless to say, I did get home, and I have a few worries to tell people. If you want to come and chat about more fighter pilot stories, I'm good with my hands and I can tell good stories. But it got me to thinking, how can I overcome this problem? There is a limitation with helicopters why they cannot fly fast. There's a particular adverse aerodynamic problem called retreating blade stall. And if you fly a typical single-disc helicopter faster than 150 nautical miles an hour, there's every chance that aircraft will depart controlled flight, pitch up and roll and crash. Consequently, typical helicopters cannot go fast. So I did a bit of thinking, a lot of talking, a lot of consideration, and I've come up with a patented methodology to allow an aircraft to fly in excess of 250 nautical miles an hour, nearly double the speed of a conventional helicopter. With that, we've also put in mind the opportunity of advanced uncrewed aircraft. So what we have developed is a vertical takeoff and landing airship that can operate beyond visual line of sight, and it's electrically powered. So we get all the efficiencies of what we want with advanced mechanics and removing gearboxes in what we needed to do. It's a sizable aircraft. This typical rollout model is 9 metres in rotor diameter. That's about the size of a Bell 407 or a Robinson 44 or 66. But we were stuck until we found this. We could not find the motor to power this aircraft. We approached YASA, we approached MREX, we approached Magnix and Magnax. None of them had the configuration that we needed desperately to make this aircraft fly. The large diameter cavity of this aircraft, the static centre, means we can build the most rigid rotor disc possible. We can fly with absolutely no concern about the high velocity that we have, and no other aircraft engine, surface vehicle engine, could match what we needed until we discovered what Donut Lab had. Here is an example of how we have set up the configuration of the rotor head. Now, to do this, again, the advantages: no gearbox. The yellow sections show how we configure the rotor head with 4 Donut Lab motors to give us the power to do what we need to do. So we can convince ourselves of the confidence nature of what we have to deliver here. An aircraft that can do over 250 nautical miles an hour. It can fly with low observability. It can take range extenders on board to fly extensive times, in excess of 10 hours. Believe it or not, we can even do something more radical, like fly in a tethered mode. So if you have a wildfire, for example, that burns down your local cell tower, we can get that recovered in a matter of hours, have a ground-based generator or electrical system to replace that in a matter of a very, very short period of time. So the flexibility we get out of having this motor, being electrically powered, to fly the aircraft without even going anywhere for an indefinite time period is unique and radical. So now we can sit back and think of the opportunities that we have been able to generate. We have an aircraft that can, for example, fly to combat wildfires. We can get out there and operate at night time. We can deliver critical supplies. We can provide medical delivery. We can fly maritime cargo delivery that is not possible in any other fashion. The opportunity that we've been provided with this motor sets a new example, a new generation of aircraft that has not been envisaged before. It's only been possible through the integration of such an advanced motor, what Donut Lab has provided for us, that gives us this opportunity. Now we truly can see where we can gain that need for speed.
Thank you, Peter. Very exciting. Okay, so what we have seen until today is the phase 1 of Donut Platform. But I do want to share a few words about phase 2. What we're building in the big picture is something that goes beyond providing these components. Yes, we are building a catalog of components, different sizes and shapes of the motor for different use cases, different size of battery modules for various applications, different versions of the electrical systems and the brain. But we're also creating this unified software architecture and tooling that will change the way how we build electric vehicles. How it will work, and we are busy building all of this, is that you will be able to simply choose your components from the catalog. Say you want to build an electric recreational vehicle. You have the chassis, but you need all the parts to make it work. You'll be able to go and say that I want 4 pieces of that motor with that torque, with that power. I want 6 of the medium-sized battery packs. I want such and such and such. And then you get them, you connect them, and we assure that by the time that you connect the wires, your vehicle works. You just saved a couple of years and maybe a couple of $100 million of integration work. But that's not everything. We are also building next generation tools for developing electric vehicles. You will be able to effortlessly integrate all the custom logic after we gave you the sensible default to start from to create the logic for motor control unit, for the vehicle control, for the battery management system, and all of this with visual software development environments without writing a single line of code to create everything that your vehicle will need without having to go deep into all the rabbit holes of individual ECUs. And what it means is that you will be able to reduce up to 90% of the development time. And what's very exciting is that once we build the logic of the vehicle on a higher abstraction layer with visual tools and translate that to the motor control unit and the other units, we are also able to translate the same logic equally to simulated environments, in 3D environments, where all the components that you've been programming will work exactly the same than what they work in the physical world. There's been a lot of talk about digital twins in the auto industry, but this is not what they mean. To actually have all the same code running and moving your vehicle in a simulated environment changes the entire game, because now anybody and everybody can write software for vehicles and check if it works. Build your own traction control system and then apply for job. Or design your vehicle before you have even a penny to spend on the hardware. But on top of that, imagine driving thousands of hours of testing on real tracks, capturing all of that data, bringing them back into the 3D simulated environment, and being able to rerun that drive every time when you make change to your code and see if everything would have worked perfectly this time. It really changes the way how you can build the software layer of electric mobility. And as I said before, we are in this massive opportunity that is growing very fast. And as I said, a lot of the innovation will be driven by the challengers. We as Donut Lab, we want to enable them all. You have heard some incredible stories today about companies that are building on top of our platform, and there's many more. And we believe that we'll be able to enable thousands of companies, changing the way how we move and how logistics work. But on top of that, of course, we are already in discussions with major OEMs from different categories of vehicles, and they also can accelerate the development time by up to 10 times. But some industries move slow, and we're not expecting that large OEMs will adopt the entire platform at once. So that's why we made sure that it's also possible to adopt individual components, such as just the motor, to get rid of your power transmission and get all the benefits of torque and power to build the kinds of vehicles with the kind of performance that has not been possible before. And we going beyond vehicles. How about robots? There'll be a lot of those in the coming decade. Well, we want to do it all, but we cannot do it alone. And that's why the big picture is that this is what Donut Lab does. But there's also a part that we expect the ecosystem and the community to do. We are providing extension points for the hardware. So any component manufacturer can talk to us and be certified to be fully integrated into the Donut platform. So anybody building their vehicles can simulate the usage of that component in the same way, can write software for that component in the same way, and can build their vehicles knowing that it all just works. On top of the hardware, we are also building an ecosystem for software, which means third-party core libraries. Say you designed a routine that can figure out the way home for a drone without using GPS. You want to make that available to the 100 other drone companies building on the Donut platform. You'll be able to do that, and that could be a business model. Similarly, if you're building remote control software for electric vehicles, this is your opportunity to integrate and make it available for all the challengers that are building the best vehicles. Or if you're an app developer or build anything else in the software layer, and you think that that would be something that you want to bring to the challengers who are changing the whole EV industry, we welcome you to come talk to us. And actually, there's some very big partnerships already underway. I just cannot mention them yet, but you'll hear more at CES, where we're announcing the first major technology partnerships related to the Donut platform. We really believe that we are doing something so groundbreaking here, for the first time creating entire ecosystem of software and hardware and vehicle manufacturers and suppliers to work together to change the status quo in every single vehicle category. As we've said, Donut platform can be used in the land, in the air, at the sea. But we've also gotten inquiries that this would be very useful for space, because there's a limited amount of energy. You need high torque, high power, and the vehicles, if you can save 100 kilos from a vehicle that you need to bring up there, that's worth a lot. And there's some exciting things happening around robots. Donut platform is available for any OEM or company building products today. And we are so excited to learn the kind of snowball effect that will start after what we are launching here today. But there's one more thing. And it's quite sad that it's a timely thing, and I'm talking of the defense industry. But we all know that dual use is an important topic today. And even the defense industry is moving out of fossil fuel. NATO has stated that by the year 2050, they want to be fully out of fossil fuel. I've talked to the directors who are leading that program, and for NATO, that's a rapid pace, because you have a long tail of vehicles. But there are some problems with bringing, say, hydrogen solutions to the battlefield. And Donut Motor is the only one that can solve them. I won't go further today, but there will be official launch of another company out of the group called Donut Defense, and you'll hear more about it on the Finnish Independence Day, 6th of December. If you're in this industry, mark it down. That's everything. That's all we have today. I have to say that this has been one of the most exciting launches that I've ever been part of. I really appreciate your attendance, and I know that all these companies here on the slide would like to talk to you. Many of them are raising funding, looking for partners, looking for employees, and all kinds of exciting things. Come and join us, and let's together change the EV industry for better. Thank you.